Alright, a listing where order is not important.
Remember yesterday when we were writing this out, we said a listing where the order is important.
So we're going to get different numbers today because that order yesterday mattered. It mattered if the blue runner got first or if the blue runner got second. But today, we're talking about like those pictures, those groups. To the group, it doesn't matter who's first, who's second. They're just in a group together. So, those of you that maybe didn't highlight yesterday, that's a big thing from yesterday. We highlighted order is important on permutations. Combinations is order is not important. Dante, Cameron, Rose. Alright, so order is not important. When we do this, it's similar to yesterday's work. It's going to have an N, lowercase n, but instead of a P for permutation, we're going to have a C for combination. Amazing. R. Now again, depending on your calculator, some calculators you actually put the N number first, then you type in that C, and then the second number, the R. With our calculators on Desmos, we do N, R afterwards. Either way, N usually comes first compared to R. It just depends on where this NCR is going to be positioned. Okay? Zach, we're doing notes. It's not that much. You can do it. Alright, what does N stand for? Good. Total objects. Nice daisies. N is our total objects. So how many are we picking from? And R is the amount needed.
So what we're going to choose.
Okay. So again, the way we say this is a little goofy. We say it as a combination. Dude. Of N, choose R. Alright, so in our calculator, we're going to find it in the same spot in that Desmos calculator. So again, Desmos, we're using that green 327 calculator. I like to invert it so you guys can see it a little bit better. Alright, so to find that, we're going to go to the function menu. We're going to hit that combination button at the bottom. Alright, for our problem this morning in that warm-up, how many runners were we choosing from? How many runners were in that race? 4. And how many did I want to pick for my winners? 2. I'm sorry, not winners, for the photo. So if I do 4, choose 2, and we did a combination, how many groups did we make? 6. And we get 6. Yay. Amazing. Alright, here we go. We're going to do 2 problems. For our first problem, we're going to talk about some friends that are carpooling. Okay. Yeah, take a ride.
You drive
like together.
So
yeah.
If you're both going to school, you pick the other one up and you drive together.
So we're gonna have 16 friends. I was thinking that they were gonna like go to the movies or Dairy Queen or something fun, not just school. Ugh. Okay, 16 friends, and we're gonna have 4 people in a car. So whether or not you can fit more than 4 people, we're going to say that there's 4 people in each car. Okay. I want to know what is the probability that Libni and Alicia get in the same car together.
So what are the chances of 16 students that Livni and Alicia will be together in a car?
Okay, now when we talk about being together in a car, we're not worried about who's driving the car, who's sitting front seat, who's shotgun, because that would be a permutation. They'd have to be in certain spots. This one we're just saying we want Libni and Elisa, there we go. Elisa to be in the same car together, which is these two friends in the car together. That would be fun. Okay? So first thing we have to do is find out how many total groups can we make with 16 friends. So we're going to find our total sample space. So we're going to ignore the fact that Libni and Elisa want to be together. So our total sample space. So we're going to do a combination. Sometimes you might just see C instead of that NCR. A combination of, again, we're not worried about them being together yet. We're just finding the total amount with that 16 friends. How many friends do we have to choose from? What's our total amount? 16. And how many friends are in each group? 4. So 16, choose 4. So we need to figure out how many total options are there for 16 people to get into groups of 4. In our calculator, we go to that function. We're going to hit that NCR 16, 4. And there's 1,820 different ways they could get into groups of 4. So 1,820 outcomes. That's a lot of different ways. Like if we took 16 people, do you think it would, I wouldn't think that it would take that long to get them into groups of 4, but then if like people want to switch around or who they're switching around, that's a lot. Alright, so now I want to know what's the probability or how many groups can Libni and Elisa be together with. So if Libni and Elisa are together in a room, or sorry, not in a room, in a car, they're already there. So how many people are there left over? How many total people do we still have left to pick now? 14. And how many do we still need? They need 2 more people. So we're going to do that combination of 14, choose 2. So that's how many we're looking for to fill their group. There's 14 people for them to pick from, and they just need 2 people to finish up their group. And again, that order doesn't matter, so that's why we're using that combination. So we'll do 14, choose 2. There's still 91 combinations for them to pick of 2 people from that 14, who they're going to pick. Alright, so for that probability, it's probability that Libni and Elisa are together. So we're going to write it as a fraction, decimal, and a percent. And this is just if everyone randomly gets in a car. Like, we aren't choosing pick your friend, get in a car with your friend, we're just randomly getting in. So how many groups were there that these 2 were together? Yeah, 91. There's 91 groups that could be created with these 2 together. There was 91 ways to finish their group. Out of how many groups of 4 total could we have made out of those 16 people? 1,820. Right, so one way to show our probability is as a fraction. We do want to simplify it if we can. So as a fraction, that'd be 1 over 20. Apparently can divide top and bottom by 91. I wouldn't have guessed that, but it would have taken me a while to figure that one out. As a decimal, that's 0.05.
Can I have your attention, please? We are in shelter.
All right, 0.05. And what is 0.05 as a percent? 5%, yeah. And if you're not sure, you can always say times 100, and we get 5. So is it likely, unlikely, even chance, impossible? It's only a 5%. It's not 50%, it's only a 5% chance. Okay? Alright, next problem, we're going to do one more together. And then you have a quick check to do, and then tomorrow we're going to practice this. Alright, number 2. We're going to be making groups of 5 students to sit at tables in our room. So we want groups of 5. Okay. Out of the 5 students in our class, we have 16 male. We have 14 female. And we have 3 non-conforming. So we have 3 students that maybe they are gender neutral, maybe they're gender fluid. They're conforming. Thank you. Okay, so we have 3 students that are non-conforming, meaning they don't identify as male or female. They might identify somewhere in between, or however they figure that out. All right, I want to know what is the probability that we pick 5 female students. When we randomly get these groups together, what's the probability that we'll randomly put a group together that has all 5 female students? When we do a probability, we first need to find our total sample space. So our first step is to find our sample space.
So in this case, what will our sample space be? What are we talking about? The total number of students, yeah? So if we have 16 male, 14 female, and 3 non-conforming, how many total students do we have?
33.
Yeah, 33. And when we talk about our sample space, we're talking about how many groups can be made out of that 33. How many groups of 5? So we're going to do our NCR combination, and they won't all be even groups. There's probably going to be one group of 4 or 2 groups of 4, but how many ways can I pick a table of 5? So how many students do I have to choose from? 32. And how many am I picking from the 33. And how many am I picking from the 33? 5. I want 5 students to sit at a table together. Okay, this formula to find this is actually pretty complex. There's lots of times where you can get that a little goofed up. I can't tell you how many times when I was your age, I hated that formula. Once I found out my calculator could just do it, whew, so happy. So 33, choose 5. We're choosing of the 33. There's 237,336 ways to create a group of 5 from 33 students. Which, how many students do we have in here? About 33. So if I wanted to just randomly pick 5 groups. Oh, Siri didn't catch that. If I wanted to randomly get 5 people in a group, there'd be 237,336 groups I could possibly make. That's insane. All right, now emails.
Can I have your attention, please?
Okay, so with 5 females, now this time I'm not looking to add anyone into their group. I want to just know how many groups from this could I make 5 males from. So I want to look at just the females. How many students that identify as female do I have in my classroom? 14. And I want to know how many groups can I make when I pick 5 of those 14. All of these groups are going to just have only students that identify as female. So we have 14, choose 5. And we have 2002. So of the 237,336 groups that we can make, only 2,002 of those groups are all female groups. So the probability of randomly picking 5 females how many groups have 5 females in them? 2,002 groups can be made with just females. Out of how many groups can be made in the entire class? 237,336. See if we can get that to be a nice, easier fraction to deal with. 237, 336. It's still not that easy, but simplified, so still need to write that down. 91 over 10,788. As a decimal, that'd be 0.00843529848. And it probably keeps going on and on and on. So if I was going to round it, if I want the nearest hundredth, so 2 decimal places, would it be 0.00 or would we round to 0.01? Which number tells me to round to 0? The 8 is more than 5, so it tells me to take this 0 and go up to 1. So what percent is 0.01? 1%. And if you're not sure, you can always say times 100. And we say it's 0.8, and that would round to about 1%. So if I was picking a group of 5 from this class of 33 students, the random chance that I would pick all 5 females is only about a 1% chance. Which makes sense. If I look at 33, is 14 half of the people even? No. It's less than half, and as soon as I add in a single other person, it would ruin that chance. Alright, real quick, I want everyone to listen, because we're going to talk a little bit about our plan for the next week or so. Alright, this is our last lesson of Unit J. So J was really short. It's only 5 lessons. K is also going to be really short. It's 4 lessons. We took a big chapter and just broke it into 2 smaller ones. So because this is the last lesson, we'll have a quick check today. Tomorrow we'll do a practice. Friday we're going to do a review. Monday will be our 1-pager. And your test will be Tuesday. Okay? So your first test for this trimester is Tuesday.